Right, David Cann here with another question from the question bank in the style of what you find in your Hayes&Harris Math SL textbook in Chapter 2E.3. In this question we have a square, A, B, C, D, and the sides of each of the square is 4 centimeters. So that's 4 centimeters, 4 centimeters, 4 centimeters, 4 centimeters. The midpoints of each side are P, Q, R, and S, and they form a second square. First off, we want to show that the length PQ is 2 root 2 square centimeters. 2 root 2 centimeters. Well, PQ is the hypotenuse of this right angle triangle. If AD is 4 centimeters and P is the midpoint, then we can pretty safely say that this length is 2 centimeters, as is this length. And this is what we want to find, PQ. Well, we'll use a Pythagorean theorem. PQ squared is equal to side squared plus side squared. That's 4 plus 4, that's 8. So PQ squared is 8, which means that PQ is the square root of 8, which is the square root of 2 times 2 times 2, which is 2 root 2. That's what we were asked to show. Then we have part 2. We want to now find the area of PQRS. Well, now that we know that this is 2 root 2 and that this is a square, we can say that this side is also 2 root 2. So the area then is just 2 root 2 times 2 root 2. That's the same thing as PQ times PQ. Well, this is QR, but they're the same length. So that's the same thing as PQ squared, which we already know is 8. All right, so we know the area of this little triangle is 8 square centimeters. Moving on, we now find the midpoints of PQ, QR, RS, and SP and form a third square. We want to write down the area of the third square, and we'll do it in the same way. If this PQ is 2 root 2, then again it's pretty safe to say that half the distance of 2 root 2 is just root 2. And so WX is again the hypotenuse of another right angle triangle. So for part 1, we'll say that WX squared is root 2 squared, side squared, plus side squared. That's 2 plus 2, that's 4. But we want WX, not WX squared, so we'll take the square root of both sides. Square root of 4 is 2. Now, I suppose anytime I take the square root I need to worry about positives and negatives, but I'm talking about lengths here, and there's not much scope for a meaningful negative length, so I'll just stick with the positive answer, 2. If I want the area of the triangle, or not triangle, area of the square, that's going to be side times side. I did just determine that each side is 2, so that's just going to be 2 times 2. That's 4 for part 2. Oops, that's still part 1. So I found the area. The area is 4, which is 2 squared. Now I need part 2. Part 2 says to show that the areas of the 3 triangles, the big one, ABCD, the medium one, PQRS, and the little one, WXYZ, form a geometric sequence, and we want to find the common ratio of this sequence. So to form a geometric sequence, they need to have a common ratio. We need to multiply by the same number again and again to go from one to the other. So we'll have an area of the big triangle, area of the medium triangle, and area of the little triangle, and we'll compare these 3 areas. The big triangle, going all the way back to the beginning, had sides 4 and 4. 4 times 4 is 16. The little triangle, or the medium one, sorry, has an area of 8 square centimeters. And the little triangle we found has an area of, 4. Did I say 2 before? It's 4. 2 times 2, 4. The length is 2, the area is 4. So the little triangle's area is 4 square centimeters. So is this a geometric sequence? Well, to go from 16 to 8, 16 divided by 8 is, 8 divided by 16 is a half. And to go from 8 to 4, 4 divided by 8 is a half. So I multiply by a half in this step, and I multiply by a half in this step. I do the same thing each time to move from one area to the next, which means that the common ratio is a half, and this is a geometric sequence.